All right, so we're going to start chapter 1, section 7. We're going to solve linear inequalities in one variable. Now, this is definitely something that you've seen in Algebra 1. It's going to be just like solving a linear equation. The only exception is that when you're dividing or multiplying both sides of the inequality by a negative number, the direction of the inequality symbol flips. Now, you've definitely seen this before. You've seen the inequality statement. You've seen the graph, right? So the inequality statement being like, okay, maybe x is greater than 10 or something like that. The graph being the little number line, right, with a value, let's say at 10. And then there's like the little open circle and the closed circles, and then shaded a certain direction. The thing that might be new is interval notation, right? And I'll show you how all of these are gonna relate to each other in the next slide. All right, so now we're gonna fill this page up. You're gonna see exactly what each of these mean in both a number line and in interval notation, right? Which again is probably new to some of you. I'll start with x is greater than any number, and x is greater than or equal to a number. So big difference between these two, right? So between this one right here and this one right here is the little line underneath it, right? So you probably know what this means. The little line underneath it means that the inequality is with equality. The one above it, right, is a strict inequality. You cannot have equality, right? So I'm going to pick, this might be a little abstract, so I'm just going to pick a number. Let's say x is greater than 5, right? So if x is greater than 5 and x is greater than or equal to 5, right, these mean two different things, right? So in both of them, you can have numbers that are bigger than 5 as a solution. But the one underneath it means that 5 itself is allowed to be a solution. You're allowed to have 5 is equal to 5. In the top one right here, you are not allowed to have 5 is greater than 5, right? Because this is a strict inequality, right? Now, the graphs of these are going to look very similar, right? And you probably remember, so at 5 right here, if it is a strict inequality, this is an open circle at 5. And if you want numbers that are greater than 5, you're going to shade to the left, or I'm sorry, to the right. Yeah, to the right are numbers that are bigger than 5. And then the one underneath it, again, we can have a point right here at 5. Since it is with equality, that means we want to write a closed circle, right? So a closed circle means that that number is a solution, right? So then again, we're going to shade to the right. Now, again, you've probably seen these before. Now, the new thing here is interval notation. Now, interval notation is read as an interval, right? From left to right, that describes the solutions to your inequality, right? And it's always going to be from left to right, right? Because how do you write a paper? How do you write a book? It's always from left to right. Now, at the very left of this number line, right? So at the very left, the most left that you can possibly go is towards negative infinity, right? And then the most right that you can go, right? So the rightmost point that you're able to reach is positive infinity. Now this first one right here, x is greater than 5, to write this in interval notation, again, going from left to right, the leftmost solution is going to be at 5, right? But because we're not including 5, we see an open circle here. We're going to write a parentheses around that 5. And then comma, the most right point that we can go is anything bigger than 5, right? There's no restrictions as long as it's bigger than 5. So we're going to go towards infinity. And then we're going to close it with a parentheses. Now, the key thing to note here is that if you see an open circle, it is parentheses. And if you see a closed circle, it is a bracket, right? So I'll do the same thing underneath it with x is greater than 5, right? Or greater than or equal to 5, right? Again, we have a closed circle at 5. right? So again, going from left to right, right? If our leftmost is negative infinity and our rightmost is positive infinity, right? The most left solution to x is greater than or equal to 5 is going to be a bracket around 5 because we can include 5. And then the rightmost point is going to be at infinity. Infinity is always going to be a parentheses because there's no, infinity is not a number, right? It's just something that you're tending towards. It just means you're getting more and more positive, right? So in purple, what you see are our answers in interval notation. Now I showed this in class, so I'm going to write it off to the side. If you think you're going to forget and you want to do it in a little chart, I'm going to write it right here. So we have an inequality symbol, right? A circle, and interval notation. Interval notation. All right, so let me make a little chart. If your inequality symbol is a strict inequality, meaning it doesn't have that line underneath it, we're going to have an open circle, right? And it's going to look like that. And in interval notation, we're going to have parentheses. All right, so something, comma, something. And then for inequalities that have the line underneath, so inequalities with equality, we're going to have a closed circle. And we're going to use brackets. We're going to denote the closed circle using brackets. Right, so bracket, bracket. All right, so just a quick way to summarize it. We can apply the same logic to x is less than any number. Right, again, so again, we can pick maybe x is less than 5. If there's a number 5 right here, and it's less than 5, well, it's not with equality, so it's going to be an open circle, right? You don't see the line underneath. And because anything less than 5 is a solution, numbers that are less than 5 are going to be to the left of this number line, right? Same thing underneath it. If I have x is less than or equal to 5, right, pick a number 5 right here, we're going to have a closed circle. We're allowed to have 5 as a solution. Right, and then anything less than 5 is to the left. And how to write these in interval notation? Well, the leftmost point that you have as a solution, right, is anything that's less than 5, right? So negative infinity. We're going to start at negative infinity, again, going from left to right. And the highest value that we can go is 5, right? And then in this top one right here, x is less than 5, right? So it's going to be a parentheses because we are not including 5 itself as a solution, right? So the open circle on 5 means it stops at 5, but we cannot say that 5 itself is a solution, right? So that's what we mean when we write this parentheses. Now the one underneath it is going to look very similar, right? We're going to start at negative infinity, right? Because that's as left as we can possibly go. And then the biggest value that we can go, so the rightmost solution is going to be at 5, but we are allowed to include it. There's a line underneath it in this inequality symbol. So we're going to write it with a bracket, right? Meaning we can go up to and including 5, right? So what you see in purple here is our solutions in interval notation, right? So it might be a little bit different from what you're used to, but once we start working with them and once we start solving some inequalities, all right, you'll get used to it pretty quick. And now this one right here, if I have a number a is less than x is less than b, right? So let's pick a number a right here and a number b right here. If I have a is less than x, right, that means there's an open circle here because a is not a solution, right? And if a is less than x, right, that means x has to be bigger than this a value right here. So we're going to go in this direction, right, going that way. And now doing this portion of it, x is less than b, right, again, you're going to have an open circle at b because we are not including b in our solution. And if x has to be less than b, anything less than b is going in this direction, right? So they kind of meet in the middle, right? So this is where your solutions are as a graph, right? You don't have to have this little, this is where this little lump right here is where I had my arrows. that we're meeting, right? But you really just need to show that it's shaded, right, in this little section right here. And in interval notation, again, going from left to right, the most left that you can possibly go is your value at A. The most right that you can go is at B. And then from left to right, you're not including A, so it's a parentheses. You're not including B, so it's a parentheses, right? So it's just parentheses A comma B, parentheses, your answer in interval notation. All right, and then same thing over here. It's going to be very similar. If I have a value A and I have a value B, right, it's going to be the same thing as in x is in between these two values, right? So we're going to shade over here. But this time we have the line underneath. We have equality. So we're going to write closed circles over A and B. And because we have closed circles and we can include these values, we're going to write A comma B with brackets in interval notation, right? Because we are allowed to include these values in our solution, right? Hopefully we're following so far. Let's look at these last two. These two are a little strange. Not really in a graph. In a graph, it might make sense, right? So let's just graph one by one, right? So I'm going to graph over here if x is less than A or x is greater than B. Let me just pick the same 2 points. Let's say A is right here, B is right here. If x is less than A, right, let's first graph that. Well, we need an open circle over A. And if x is less than A, anything less than A is in this direction, right? So we're going to the left. And if x is greater than B, right, where's B? Is right here, and it's going to be another open circle. You don't want to include B in your solution. And if x has to be greater than B, anything greater than B is to the right. So we have this little gap in our number line where we don't have solutions. Now to write this in interval notation, right, for x is less than A, right, you start at negative infinity, right? So we're going to start there, negative infinity with a parentheses, and we're going to end here at A with another parentheses. For x is greater than B, we're going to start at B, right, going from left to right, and then we're going to approach infinity, right? So the highest that we can go is infinity. Now this itself is not complete, right? We want to join these two intervals to show that they are part of the same solution, and to do that we have a little u in between it, right? A little u without the leg. This u represents the union of these two intervals, meaning it can be either in the interval from negative infinity to A, or it can be in the interval from B to infinity, right? So that's just what that union means, right? We're not going to use it in this lesson, right? But it's helpful to know for the future lesson, right? The one after this. All right. Now, the last one is going to be exactly the same, just with equality, right? So if x is less than A, if A is right here, or less than or equal to A, we have a closed circle at A, and we're going to go to the left. And we're going to have a closed circle at B, and we're going to go to the right. And then to write this answer in interval notation, we're going to start at negative infinity up to A. This time with a bracket, we are including A. We're going to start again at B, right? We have a little gap up to infinity with a u in between, a union, right? Now this is our answer in interval notation. Now let's practice some examples so that we can kind of get used to this. All right, so let's look at the first one. So we're going to solve, graph, and put it in interval notation. Now solving is the easy part. It works the exact same way as it would just a linear equation, right? Let's get the x by itself and get our constants to the other side. So we get 2x is greater than 16. And then we divide both sides by 2. We get x is greater than 8, right? So this is our answer as an inequality statement. Now to write our answer in a graph, right, let me just draw a little number line, right? And if we have a value here at 8, right, well, first, are we going to have an open or a closed circle? All right, this one's going to be an open circle. It's a strict inequality, right? So we're going to have an open circle, and we're going to the right or to the left. We're going to be going to the right, right? Because anything greater than 8 is going to be in this direction, right, so there's our graph, and in interval notation, we're going to start at 8, right? So going from left to right, we're starting at 8 up to infinity. We can have anything that's bigger than 8. And we're going to have parentheses around these, right? There's always a parentheses around infinity, again, because it's not a clear value, so you can't be at infinity. But we're going to have a parentheses around the 8 because it's an open circle. We're not including it, all right? So that's what the parentheses represents, all right? And then this would be, these are all three of your answers, right? As a statement, in a graph, and in interval notation. All right, so let's try the same thing with the next one. All right, solving for x is the easy part. Let's get the x by itself, move the 2x, and move the negative 3. So we should get 5x is less than or equal to 10. And then divide by 5, we should get x is less than or equal to 2. All right, so this is your answer as a statement. And now as a graph, right, at 2, we're going to have a closed circle because it's with equality. So 2 is allowed to be a solution, and we want anything less than 2. Right, so we're going to the left. And on to write our answer in interval notation, going from left to right, we're going to start at negative infinity. All right, this is the most left as we can go. Right, so negative infinity, we're going to go up to 2. And we are including 2. There is a closed circle, so we're going to have a bracket. Right, so in purple is our answer in interval notation. All right, and let's look at number 3. Now, number 3 looks a little different because you have a fraction. You don't have to clear the fraction, but I know most of you don't like the fractions, so naturally we want to try to make it a little bit easier. Right, so let's multiply this entire thing by the denominator, right, so by 2. And then let's distribute 2 to everything. And we get 2 minus the 3 halves, and the 2 are going to cancel. And we're going to get 3x is greater than or equal to 2x minus 8. And now we can start solving normally. Right, so let's get the 2x to the other side. And let's get the 2 to the other side. And then we end up with negative 5x is greater than or equal to negative 10. And now we're dividing by negative 5. Remember what happens when we divide by a negative, though. Here, the inequality symbol is going to flip. Anytime you divide or multiply by a negative number, the inequality changes direction. Do not forget that step. It's really important. You'll get completely different answers. And this is your answer as a statement, as an inequality statement. Right, so now let's graph it. I'm going to write a little number line, right, and a point at 2. Right, and we are going to have a closed circle at 2 because it's with equality, and we are going to the left, right? We want anything that's less than or equal to 2. All right, and then to write it in interval notation, from left to right, we're starting at negative infinity. So parentheses, negative infinity, and we're going up to and including 2, so it's a bracket. All right, so hopefully you're seeing it's not super difficult, right? Just a little bit new. All right, and this last one's going to work the same way, right? If you want to clear that fraction, again, you don't have to if you're okay with combining whole numbers and fractions, right? But naturally, you might want to try to make it easier, right? So multiply everything by the denominator, which is 3, right? And then that 3 is going to cancel with this 3, and then you have minus 5x. 3 is going to multiply with everything else. So we're going to get 6 minus 5x is greater than 3x minus 18. And then solve for x, so let's subtract 6 and subtract 3x. So we get negative 8x is greater than negative 24. And then you can divide both sides by negative 8. And then again, you're dividing by a negative number, your inequality changes direction. We get x is less than 3. And there's your answer as a statement. And now to graph it, we're going to have a point at 3. Now here, it's a strict inequality, so we're going to have an open circle. And we want numbers that are less than 3, so we're going in this direction. We're going to the left. All right, so there's our graph. And then to write our answer in interval notation is going to be a parentheses, negative infinity. That's the most left that we're going. And then our answer that's most to the right is going to be at 3. with a parentheses. Right, so those are all three of your answers. And then again, hopefully you can see it's not super difficult. Now, I'm going back to record this part because I was reminded of it after the fact, but I saw some people in class, once they got to this step, so once they got to that step right there, do it the other way. So maybe decided to, let me see how I can write this. Or let me just rewrite it. So 6 minus 5x is greater than 3x minus 18. Okay, so a distinction that I want to make here is that if you're deciding to move the 5x to this side and the 18 to the other side, you will still get the same answer. All right, so let me write it over here. You still get 24 is greater than 8x, and then divided by 8, you get 3 is greater than x. Now, when it comes to the graph, some of you get confused because you were taught to think of the inequality symbol like an arrow, right? And I even teach that to my freshmen, right? So I teach them to look at the inequality like an arrow, but this is only true if your variable is written first. So if you want to use this little arrow method, then you would need to rewrite the entire inequality first with the variable, right? So if you want to write the variable first, it's going to be x is less than 3, right? So hopefully you see that these two are equivalent, and then you would get the same answer. But just be careful with the arrow, right? Because even though it looks like it's pointing in this direction, really your solutions are going to be to the left of 3. Right, going in this direction, right? So you can leave it like this if you don't want to think of it like an arrow, right? If you can just think to yourself, what is this saying? This is saying that 3 is bigger than any value x, and so any solution that you have has to be less than 3, right? So hopefully that clears things up if you did it the other way, and then maybe you were graphing it and you got a different graph than I got. Right, really we should be getting the same thing. Okay, let's try a couple more. These ones are a little bit different because here now we have two inequalities in the same inequality statement, right? So we have to deal with two different ones, but keep in mind our variable is in the middle between these two. So this is where we're going to be doing our inverse operations. Right, so we're going to start by getting rid of that 2. And if we add 2 here, we have to add 2 to every single part of this. Right, every single part of our inequality. And we're going to be left with negative 2 is less than or equal to 5x is less than 9. And then the last thing you want to do is divide by 5. And then you get negative 2/5 is less than or equal to x is less than 9 over 5. And this would be your solution as a statement, right? Don't worry about the fractions. As long as you have the x by itself, you're good. And if you're writing a number line, it's not that serious. You can really just draw a line anywhere and say that that's negative 2/5, and a line over here and say that this is 9/5, right? And so when you want to graph your inequality, look at the negative 2/5 and the x. There is an inequality that has the line underneath, so we're going to have a closed circle there, right? But the other one, if x is less than 9/5, you're going to have an open circle there, right? So you can have two in the same statement, right? It's not a big deal. And then you want to shade in between, right? Because x is in between these two values, all right? And then to write it in interval notation, going from left to right, our leftmost solution is going to be at negative 2/5, and we are including it. It is a closed circle, so it's going to be a bracket. And then our rightmost solution is going to be at 9/5, and we're not including it. It's going to be a parentheses, right? So same process as always, just you have something that looks slightly different, right? But really, it's no big deal, right? We can handle it. All right, now looking at this one, again, same process. Our x is in between the two inequality symbols. So this is where we want to do our inverse operations. Let's start by adding 1 everywhere. And then we get negative 2 is less than or equal to 6x is less than 4. And now we can divide 6 everywhere. And then negative 2 over 6 can simplify to negative 1/3 is less than or equal to x is less than 4 over 6 can simplify to 2 over 3. And then this would be your solution as a statement. And then writing it on a graph, you're going to have a point right here at negative 1/3, and then a point right here at 2/3. All right, and then you're going to have a closed circle at negative 1/3, right, because you see the equality underneath, and then an open circle at 2/3. This one's a strict inequality, and x is in between, so we're going to shade in between. And then to write in interval notation going from left to right, we're going to have negative 1/3 with a bracket, comma, 2/3 with a parentheses. Right, we are including the negative 1/3, but we're not including the 2/3. All right, and then let's look at the next one. All right, same exact thing. Our x is in the middle, so let's subtract the 7. To get it by itself, let's subtract 7 everywhere. And then we end up with negative 6 is less than 2x is less than 4. And then let's divide 2 everywhere. So we get negative 3 is less than x is less than 2. And then this is our answer as a statement. Let's graph it. All right, so we have a negative 3 and a 2. And we have open circles on both. Right, these are both strict inequalities, but we're shading in between. All right, and then to write our answer in interval notation, from left to right, we're starting at negative 3, and we're going up to 2. Both have parentheses because we're not including either value in our solutions. All right, not bad. So let's look at the last one. Again, as before, you don't have to deal with fractions if you don't like fractions. Right, so you can multiply everything by 3 to get rid of that denominator, right? Because if you have a denominator of 3, it's going to cancel out if you multiply by 3. And then distributing that 3 everywhere, we're going to get 3 times negative 4 is negative 12, right? Is less than or equal to 2, right? Because the 2/3 and the 3 cancel, minus 3x is less than 3 times 5 is 15. All right. And now let's get the x by itself. Let's subtract 2 everywhere. And then we get negative 14 is less than or equal to negative 3x is less than 13. And then divide by negative 3, right? But don't get confused here. Dividing by a negative, you have to change the direction of your inequality. So we're changing all of these, right? Both of them. And then negative divided by negative becomes positive. So we get positive 14 over 3 is greater than or equal to x is greater than negative 13 over 3. All right, so all of our inequality symbols change. Now here, I would flip the entire thing. I mean, it wouldn't be bad if it was left like this, but I mean, I would flip the entire thing just so that graphing and writing in interval notation is a little bit easier. So let's start by writing negative 13 over 3 is less than x is less than or equal to 14 over 3. And now everything makes sense, right? We're going from smallest to biggest. And now it makes sense to graph it, right? So let's graph. We're going to start at negative 13 over 3. And we're going to go up to 14 over 3. And at negative 13 over 3, we're going to have an open circle. At 14 over 3, we're going to have a closed circle. Right? And we're going to shade in between. And then in interval notation, our leftmost value is going to be at negative 13 over 3. Right? So that's our smallest solution, and we're not including it, so it's a parentheses. And our biggest value is going to be 14 over 3. Right? And we are including it, so we're going to have a bracket. All right? So not bad, right? It's just like solving linear equations. Just little extra steps with the graphing and the writing and interval notation, right? But hopefully this helps.